All right, Math 2 3.8, the quadratic formula. So the quadratic formula, if you have a formula or an equation in the form of ax squared plus bx plus c equals 0, if you have something like that where you have a, b, and c, then you know that x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. And that's a big deal. That makes completing the square kind of obsolete. You don't have to do that right anymore. It's still useful to do sometimes, completing the square is, but I think this helps a lot. Before we continue, I want to show you where the quadratic formula came from, or how we can get it. And it comes actually from completing the square in a fancy way. So let me see if I can pull my screen over to the side. All right. So if you have ax squared plus bx plus c equals 0, and we want to solve for x, right? We're going to do this all using the variables there. Normally we would have like some numbers there, but we're going to complete the square and everything, leaving all the variables, okay? And we're going to end up with the quadratic formula. So let's first start off by getting the x's on the side on their own. So we'll start off by saying, well, we have ax squared plus bx equals negative c, because c is we moved c to the other side. Next up, we always got rid of the term in front of the x squared. So we're going to divide everything out by a. So we're going to have x squared plus b over a x equals negative c over a. Okay. Now we're able to add in our blanks. So I'm going to say, well, I have x squared plus b over a x plus blank equals negative c over a plus blank. Now, we used to do b over a squared, right? That's what we would do. Now, something's a little bit off here. We have b over, oh, not b over a, excuse me, I'm sorry. B over 2 squared. There it is, b over 2 squared. But b over 2, we already have a b here. So we can't really think about it like that. Let's change this letter here and let's make it a j. It doesn't really matter what letter you make it, but we know that j is this guy over here, b over a. So this guy here is going to be the same thing as b over 2a squared, which is b squared over 4a. Okay? Oh, 4a squared, excuse me. So right here in our blanks we have b squared over 4a squared. Okay? That's kind of a tricky step there because it looks kind of weird because we have all those variables. But now that we're down here, this stuff on the left, we're able to factor into x plus, what is it, b over 2a? Yeah, b over 2a, and the quantity squared. Right, I'm able to grab this b over 2a from right there, just like how I would normally do. And then this stuff on the right, I'm just going to leave it as is. I'm going to have negative c over a plus b squared over 4a squared. Now, before I continue, I want everything that's on the right side of the equal sign, I want it all to be one fraction. So what I'm going to have to do is I'm going to have to get common denominators. The right denominator, the denominator on the right, I have 4a squared. I want to decide how could I turn a into 4a squared. Well, I would need to multiply by 4a times 4a, right? Then that would be 4a squared. So I'm going to multiply the top and the bottom of the negative c over a term by 4a. So my next step, or the next statement, is going to be x plus b over 2a quantity squared equals negative 4ac over 4a squared plus b squared over 4a squared. Okay? Now, just This will make sense in just a second, but what I'm going to do is I'm going to swap the spots of these two. Because this one's positive and the other one's negative, it'll look a little bit nicer, and I'm going to combine them together in that term too. So I'm going to have x plus b over 2a squared equals b squared minus 4ac over 4a squared. And that should start to look like the quadratic formula there. We can kind of see that this guy here, that statement there is exactly in the quadratic formula. So let's now take our roots, and we're going to have x plus b over 2a equals plus or minus the square root of b squared minus 4ac all over the square root of 4a squared. Okay? Let's say x plus b over 2a equals, and we can reduce some things there. Let's put the plus or minus in the numerator. Okay? Now the square root of 4a, that's the square root of 4, which is 2, square root of a, which is a. Okay? And very last step, we're going to get the b over 2a the other side. So I'm going to have, well, x equals negative b plus or minus square root b squared minus 4ac. Now, for my denominator, both of these are 2a. So I could put the whole thing with a 2a. And this right here is the quadratic formula. So I know it takes a little bit. It's kind of wonky how it gets there. But you can kind of see how completing the square does end up giving you the quadratic formula, right? We didn't just pull this formula out of some crazy spot. Some people sat down and they worked on this for a long time. I would not have came up with this on my own, but I was shown it once, so now I know, or shown it a few times at least. So let's use the quadratic formula to solve these problems. So let me scroll in here. You're going to need to memorize this. You're going to need to have it written down. You're going to need to know it. Trust me, it makes it a lot easier if you do memorize it rather than having to go on your notes. So number one, we have A, B, and C. So we have M equals, right, normally it was X equals, but here our variable is M. M equals negative B, negative 8, plus or minus the square root of B squared, 8 squared, minus 4 times A, which is 10, C, which is 7, all over 2 times A, which is 10. All right. The rest of this problem is just simplifying this down. All right. A lot of it can be typed in your calculator. So we're going to have negative 8 plus or minus root 64 minus, I don't know what that's going to be. What's 7 times 4? 28, 280, 280 over 20. This is the same thing as, what if let me get my calculator. 64 minus 280, I can say, well, this is the same thing as negative 8 plus or minus root negative 216. All right, sorry, I got a phone call. So we've got negative 8 plus or minus root negative 216, and then we've got our denominator still of 20. Now, 216, I want to say is a perfect square, but I'm not 100% on. Let me check it in. Let me type it in. Root 216. Yeah, no, it's not. We can pull out an I though, so let's do that. We'll say negative 8 plus or minus I root. Let's take apart 216. So 216. Well, we can divide by 2. 216 divided by 2 is 108. Divided by 2 is 54. Divided by 2 is 27. Divided by 3 is 9. And then we have another 2 3s. So we have a pair of 2s, a pair of 3s, a single 3, and a single 2. So outside of the root, we have 2 times 3. Inside the root, we also have 2 times 3. Right, so these two, the 2 and the 3 outside came from here, The 2 and the 3 on the inside came from here. So I've got negative 8 plus or minus 6I root 6 over 20. And now here's a little kind of a trick, kind of like a sleight of hand kind of thing. I have an 8, a 6, and a 20. This 8, 6, and 20, I can take a 2 out of it all, and I'm going to be left with 4, 3, and 10. So my final answer is going to be negative 4 plus or minus 3I root 6 over 10. And that is our final answer. All right, number 2. You always have to have it equal to 0 on either the right or left side, depending on how you want to do it. But I want it equal to 0 on the right, so I'm going to put this 3 over here with the 11. So I'm going to have 10a squared minus 10a plus 8 equals 0. So here's my a, here's my b, and here's my c. So I'm going to plug into the quadratic formula. You need to have that note out, be able to look at it, and be able to follow along with me as I do it. So we're going to have a equals, this time it's a because our variable is a, 10, let me get my pen working right, 10 plus or minus the square root of negative 10 squared minus 4 times 10 times 8 all over 2 times 10. X equals the opposite b plus or minus the square root of b squared minus 4ac all over 2a. Yeah. I was just double checking it on my own. So I've got 10 plus or minus, and then big root 100 minus, I think it's 220. Let me check. Or 320, 320, and then a 20 on the bottom. So I've got a equals 10 plus or minus root negative 220 all over 20. I need to take this negative 220 out to the side. I'm just going to take 220 out to the side and split it up. So I've got 22 and 10. So I have a single 11, a single 5, and then a pair of 2s, right? So let's rewrite this. I've got 10 plus or minus 2I root 55 over 20. Right? So my 2's came out. These two 2's came out here. And then my 5 and my 11 make my 55. Now, just like in number 1, we've got to do that little bit of canceling right at the end. We have a 10, a 2, and a 20. They can cancel, and I get 5 plus or minus I root 55 over 10. And that's my final answer for number 2. Okay, number 3. Again, we have to have it equal to 0. So I'm going to say, well, negative 2x squared plus 1x plus 66 equals 0. Now I have my a, my b, and my c. So I'm going to have x equals negative 1 plus or minus the square root of 1 squared minus 4 times negative 2 times 66, all over 2 times negative 2. This is the same thing as negative 1 plus or minus root 1 plus, right, because we have 2 negatives, so let me type in my calculator, 4 times 2 times 66, and I get 528, all over negative 4. This is the same thing as negative 1 plus or minus big root of 529 over negative 4. Now, if it ends up being that you have a huge number under a root, I would just try and check and see if it is a perfect square. So 529, take the root of 529, and I just typed that in my calculator, and I got 23. So I've got negative 1 plus or minus 23 over negative 4. Okay. Now, you could leave it this way, but I think it's whenever you get rid of the root and everything, it's a lot easier, or it's kind of nice to end up with actual numbers as your answer. So I'm going to split this up into two different ones, one with a plus and one with a minus. So I'm going to say negative 1 plus 23 over negative 4, and the other one's going to be negative 1 minus 23 over negative 4, right? So the one on the left, I got 22 over negative 4, which is the same thing as negative 11 over 2. And the other one, I get negative 24 over negative 4, which is 6. So I have actual numbers as my final answer this time. And we have two answers because normally they're held up in that plus or minus. We always have two answers. This time we're able to actually see both answers. All right, number 4. We'll notice here that we don't have a plain old n. So we're going to have to put one in as a 0n. So I'm going to say, well, I've got negative 3n squared plus 0n. And then I want that 27 over on the left, so plus 27 equals 0. So here's our A, our B is 0, and our C is 27. So n equals negative 0, which doesn't make a whole lot of sense, but that's okay. Plus or minus the square root of b squared, 0 squared, minus 4 times negative 3 times 27, all over 2 times negative 3. So this is the same thing as plus or minus root. I'm going to do 4 times 3 times 27. I got 324 all over negative 6. The square root of 324, if you type that in just to check, is 18. So we have plus or minus 18 over negative 6, which is the same thing as, well, 18 divided by 6 is 3. Now, I kind of lost this negative in that step, but it doesn't really matter because I have the plus or minus. If you have a plus or minus and then a negative also in the same term, they kind of reverse it. It's just okay to let that negative go. So we have plus or minus 3, which means 3 or negative 3. And we have actual number answers, just like we did in number 3. All right, I want to jump down to number 6. You guys can work on number 5. But number 6, I've got v squared minus 4v plus 8 equals 0. So my a is 1, my b is negative 4, and my c is 8. So I have v equals 4 plus or minus the square root of 16 minus 4 times 1 times 8 all over 2 times 1. Let's pull that a little bit apart. Yeah, there. Oops. Yeah, I didn't like how close those were. So this is the same thing as 4 plus or minus root. Let's do 16 minus 4 times 8. You could type in the 1 if you wanted to, but there's no real need. So we got negative 16 there over 2. Well, this is the same thing as 4 plus or minus, well, we have an I, and the square root of 16 is 4, so our root goes away completely, and then we have a 2 on bottom. Well, this is the same thing as, you can cancel the 4's and the 2, it's 2 plus or minus 2i. And if you wanted to, you could split this up into 2 plus 2i and 2 minus 2i, but I'm okay with it staying right like that. All right, let's go straight down to number 8. Number 8, we'll put everything on the left. Negative 7r squared minus 3r plus 17 equals 0. Now, just as a note, you could have put that 7r squared on the right, and your a would be positive and everything would be flipped signs. Your ending answer would be the same as mine. So if you want to do that and then follow along with mine, you're welcome to. I've just gotten in the habit of putting the 0 on the right. That's just a force of habit. So I have r equals 3 plus or minus the square root of negative 3 squared minus 4 times negative 7 times 17 all over 2 times negative 7. We can multiply out, and we get 3 plus or minus big root, and negative 3 squared is going to be 9, and then we're going to say minus 4 times negative 7 times 17, and I get 485 under the root. And then on the bottom I have negative 14. Now, 485, let's try to split that apart. 485. Well, I know I can divide a 5 out of that. No, wait. Yeah, 485. Good grief. Divided by 5 is 97 and 5. 97, what can I divide out of that? Can I divide a 3? No. Can I divide a 7? No. I'm not seeing anything that I can divide the 97 into. So I'm thinking this won't help, and we're just going to have to leave it as root 485. So our answer is going to be 3 plus or minus root 485 over negative 14. Now, on CUDA-Works, sometimes they change some of the problems, or change some of the answers, and they don't like having a negative in the denominator there. Sometimes what they do is they end up removing that negative and putting it up top. So they end up making this negative 3 plus or minus root 485 over positive 14. And what they really do here is they multiply the top and bottom by negative 1. So the negatives cancel. The negative 1 goes with the 3, but then the negative 1 and the plus or minus, well, that just kind of flips the plus to a minus and the minus to a plus. So nothing exciting happens there. And the CUDA answer is going to look a lot more like that, only it's going to be separated into one being a plus and one being a minus. All right, I know I skipped some problems, but I think you'll be okay with that. So there we are.